Hello everyone, I am Divanshu Kumar and today I will be discussing a problem named Biladerim Icin. This problem has a difficult name, right? This problem code was LAPD. This was a question of September long 2019 code chef, right? This was a fifth difficult problem, I guess, right? So in this question we were given three triplets A, B, C, and we were told to find uh, number of amazing interesting sequences such that this relation holds ax square plus b 2bxy plus c y square is greater than x square plus y square. Now what is a, b and c? A, b and c is nothing but one is greater than equal to a is less than equal to capital A. Similarly b, one is less than equal to capital B, and c similarly, right? This was, and we have to output the total number of interesting subsequences, right? So if you have not solved this question, I would suggest to pause the video now and try solving it, right? Now I will start discussing the solution, right? So if you look at this relation carefully, so basically you can reduce this relation. How? That let me show you. Now I will start on a fresh page, right? So you're given a relation ax square plus 2bxy plus c y square is less than x square plus y square. So I will take these two on the left side, right? So I have a minus 1 x square plus 2b xy plus c minus 1 y square, right, is less than 0. Now let me have this in form of a quadratic equation in terms of x, and I will assume y is y in terms of x. So for as I'm just saying like y is somehow related to x, right? So let's just say y is independent. Y is like it will depend on particular value of an x, and only x is variable, right? Let's just say that, right? Uh, Okay, y something we don't care about. Y is also a variable for now. Don't consider anything else. Like just say this equation is a quadratic in terms of x. Okay, let's just say that, right? And you must have remembered this formula. This for solving a biquadratic equation. X equal to minus b plus minus whole root over b square minus 4ac divided by twice of a. This is nothing but biquadratic quadratic equation, right? You must have remembered this. uh, this we were taught in our school, right? I guess 11th or 12th or 10th, I don't exactly remember when, but this is a basic quadratic equation, right? And then this part is known as the discriminant, right? So b square minus 4ac, and it had three conditions, right? If it is greater than 0, then the roots are real, right? And if it is equal to 0, then the roots are equal. And if it is less than 0, then roots are imaginary, right? Roots are imaginary. Now these three conditions I hope you remember, right? And this is the quadratic equation. These b and this b are different, right? I just uh, gave a point to uh, give you quadratic equation, right? So only this part is important, that b square minus 4ac should be less than 0 for imaginary roots, right? So I will write this fact here and I will erase this part. Okay, something tells me I could have done this faster using a select tool. Okay, fine, anyways. Right, so now let's solve this equation more further. Now I'm assuming this is a biquadratic equation in terms of x, right? So to solve this x, I will get what? Minus b, right? That is minus 2b y, right? Plus minus whole root over b square is nothing but 4b square y square minus 4ac, right? So that is nothing but a is a minus 1 and c is c minus 1 into y square whole divided by twice of a minus 1, right? This is the biquadratic equation for x. Now for this equation to have always a value less than 0, right? So basically I am telling this, right, this root should never exist. It should never be greater than equal to 0, right? So x should never be equal to 0 or greater. So this discriminant part, this part should always be less than 0, right? This part should always be less than 0. Now to solve less than 0, 4b square minus y square is minus 4a minus 1 into c minus 1 y square is less than 0. Then if I take 4y square common, right, so I'll have 4y square b square minus a minus 1 into c minus 1 is less than 0. So let's just ignore this part, right? Because y can be anything, right? Uh, Here x and y, here x and y, this relation should hold for any set of x and y, right? This should hold for all x, y belonging to real number, right? So basically x and y can be anything, even 0. So let's just ignore 4y square part. And moreover, this is a square, right? So this will always be greater than equal to 0, right? So only this part should be less than 0, because 4 is a constant, it cannot be less than 0. Y square will always be greater than equal to 0. So obviously this part should be less than equal to 0. So b square minus a minus 1 into c minus 1 should be less than 0. Then b square should be less than a minus 1 into c minus 1. Now this is the only equation I need to solve to get through this question, right? Now I reduce this question to a simpler equation which I need to solve. Only these combination I need to find which satisfy this equation, right? I will clean this up, right? And I will write that equation again, that b square is less than a minus 1 into c minus 1, right? Now here I will have two cases, right? When both of these are greater than b, if it is greater than b, right, then obviously this whole term will be greater than b, right? A minus 1 is greater than b and c minus 1 is greater than b, right? Then obviously for anything this will be greater than b square, right? So how many ways I can have this is a minus uh, if a minus 1 equal to b, then b a equal to b plus 1, right? So this should be greater than b plus 1, right? So I will just subtract b plus 1 from this, right, into capital C minus b plus 1, right? This will give me part where a is greater than b and c is also greater than b, right? And second part is when any of them is less than b, right? If both of them are less than b, then obviously this case is not possible, right? A minus 1 is also a minus 1 and c minus 1 is less than b, then this case is not possible, right? Then this cannot be greater than b square, right? Then we move on to third case, like either a minus 1 is greater than b and c minus 1 is less than b, or a minus 1 is less than b and c minus 1 is greater than b, right? These two cases we need to solve, right? Then let me just write third case, right? And then I had a minus 1 is greater than b. This is easy to find. This I will be telling you how. And c is less than b, right? C minus 1, right? So basically if you see the equation clearly, b square should be less than a minus 1 into c minus 1. Now what I am telling is I can iterate from 1 to b and check for this value, right? If c minus 1 equal to 2, or then what should be the value of a minus 1? Then a minus 1 should be greater than b square by 2, right? So basically I will just iterate from 1 to b for each of b, right? For each b, then I will iterate for c 1 to b again and find what should be the value. that is nothing but b square by 2. Similarly for c, right, if then I can just consider a minus 1 equal to 1 to b, whatever it is. Let's just say this is j, then this will be j, and then c minus 1 should be greater than b square by j, right? Integer value, right? This should be greater because a, b, c are supposed to have only integer values, right? Now these now these two formulas are the basic things required to solve this question, and just this uh, just you say simplification, right? I will just walk you through the code. The code is pretty simple for this, right? If you just like and then I just defined a function for x square. Here we have defined a function for x square by y, that is nothing but which will be using for calculation of here b square by j, right? For this b square by j, so we just defined a function for that, right? And a modulus function we defined, right? So that mod we defined here, and we are just returning a mod value, right, of x, right? So let's start. For each of the test cases we are taking the input, and then for each of the b value, right? Here if you see this relation, right, this relation can be true. This relation we have to find for each of the b value, right? Here we are taking all the values for b, so we just kept a value like b can be 1 to capital B, right? So this loop we are iterating. We are fixing one of the B, we are fixing from 1 to B anything for a for loop, and then we are checking for each of that B, right? So if you check here, right, then we are checking for each of the B, like 1 is less than equal to B, and then firstly we are taking simple one, C minus I minus 1, right? That part of the case 1, right, into A minus I minus 1, right? This one, this part. If you solve this, you will get a minus b minus 1 into c minus b minus 1, right? And just we are taking if it is less than 0, then we are taking the 0 value, right? And that's all, right? And then for j equal to 2, to minimum of a of I, and then I plus 1 j plus plus, and then we are doing this just a simple one for the case 2, right? Because if you see a should be, if a is equal to 1, then this value will be 0, right? So obviously it should be greater than equal to 2. Then for from 2, then just for j equal to 2 we are taking fixing a value and finding the c value, that is c minus, this is nothing but b square c minus b square by j minus 1, right? This we are doing this, and here similarly we are doing with a minus b square by j minus 1, and then we are just printing the answer, like, yeah. And one more thing is, this solution is nothing but order of t into b square, because you can see here we have a loop for b, and then again we are iterating for 2 to minimum of I plus 1, right? That is nothing but again b, right? So basically we are iterating, so we have a solution of order of t into b square, right? So yeah, so but still it will pass because b was given to be, not test cases. Here if you see the test cases, yeah, what was the test case limit? So test case limit was only 10, right? So test case limit was 10, order of 10 into b square is 5000, so 5 into 10 is power 3 whole square, right? So that is order of 10 into 25 into 10 is power 6, right? So order of this is again 2 digits, right? So 6 7, almost order of 10 is power 8, almost, right? So basically, yeah. And one more thing is, most of my friends said like they use the same logic but they were not able to get an AC because they were getting TLE. Now why they are getting TLE? Because they used a lot of if else, right? If else, many, like if it is less than C or not. Because see here what I'm doing is, what the solution is doing is, it is taking max of 0 in this, It is not comparing like whether if it is less than c then you are multiplying and all. That it is not doing. It is just calculating one value and finally checking if it is less than 0, then it is taking 0 value, right? Similarly here also minimum value. So less number of if else and also modulus function, right? uh, so you should use less of comparisons, if because like in 1 second at max you are able to get 10 to the power 8 or 10 to the power 9 operations, right? So order of 10 to the power 8, I think that will be the maximum you can get in 1 second. So if you add any extra computation to this code, you might get one or two TLE in the last segment, right? Even I got extra TLEs, right? So basically you should keep your code concise and less number of steps, right? Otherwise this, even with this logic, because it is order of 10 to b square, it won't pass with any other cases, right? So that you should keep in mind. You should keep your code clean, means like less of computations, right? So as it does not take much of your time. Yeah, that will be all. If you still have any doubts, please do ask me in the comment section below. Do subscribe to my channel, right? Also hit like button if you like the videos of this challenge, right? uh, and subscribe to my channel. Yeah, happy coding. Thank you.